Good day, everybody. We have reached the top of the hour, but we're going to wait a minute or two for our audience to log in and find space.
I'm great. I'm ready.
But in the meantime here,
Okay. All right. Okay. All right. As we're just about getting ready to go live, let me say hi to everyone. Welcome, welcome, welcome. We have a whole presentation. We're going to talk about the metaverse and space applications. It's going to be broadcasted over WebEx and many other locations that people are going to see. We're getting set up to be able to broadcast it locally here at the Ames Research Center, one of NASA's centers for which they are hosting us today. So we're really grateful for them to provide us an opportunity to talk about some fantastic disruptive technologies that are coming up, like the metaverse. We'll concentrate on some of the space applications that are going on, and also be able to relate that to Ames Research Center, which actually is performing a number of things in this area that you may not be aware of. So we're really excited about being here today, and please hang tight as we get everything set up and get it ready to go. So once again, welcome. Thank you for your patience. And it's easier, of course, if you were all in the metaverse. Okay, if you were all right here, we'd be going, all right? But since we have our audience is a mix of people that have gone into the metaverse and others have not, and are using other types of social media, we're in that transition period, of course. But welcome to everyone that's out there watching this on whatever venue that you're able to.
We already have people joining us, Jim. We have Alison from Cumbria, the United Kingdom. We also have Ayesha in Pakistan. We have Mariam in Pakistan as well. So yeah, the audience is joining. I know also some of my family members in Canada and Colombia are watching as well. So we have people joining from all over the world.
Oh, wonderful.
Yeah.
Yeah, people are joining from all over the world. Well, that's fantastic. And they're doing it perhaps on several platforms. We're broadcasting it over several locations. So we're nearly ready. We're waiting for the introduction by the Ames chief scientist, and then I'll take off and talk about now one of my favorite subjects, the metaverse and its application to space.
Wonderful. We look forward for that, Jim. Thank you so much.
Indeed. Looking forward to it.
Jim, we have a question in the meantime from Alison. She's asking what
Camilo, we're going to start.
Oh, okay, fantastic. No
okay, we're going to start. So let us just begin, and you could deal with this toward the end at this point. So thank you.
So, Alison, I will answer your question. Jim is using an app called Cluster. You can use it from your phone, from your laptop, also from your Oculus, and you can create an account, and you can create your avatar, and you can also join us in future sessions. So remember, Cluster App Lab, you can find it online.
Well, thank you very much, Jacob. That was a wonderful introduction, way too long. I'm delighted to be back here at Ames. Ames holds a special place in my heart, so to speak. I've been working with Ames for many, many years. And today I want to talk about the metaverse and space applications and show, I think, quite demonstratively that this is a very important disruptive technology. And of course, what do I mean by that? I mean that it's going to change the way we do things, not only in the agency, but in our life. Now, this has happened in a number of occasions in my scientific career. I started in NASA in 1980. And one of the first things that I was able to do, I was challenged to do this, is connect a variety of investigators together in the United States to share data from several of our satellites. I was a civil servant at Marshall Space Flight Center, and I created NASA's first network with 6 nodes in 1980. That grew tremendously rapidly. We had a remote logon, mail, messaging. We had so many things that you take for granted today. This was revolutionary. We could write proposals in separate locations and bring them together and communicate as we do today. But back then, that was revolutionary. That was disruptive. My interaction with Ames began in the late 80s as they also had the opportunity to interface with the National Science Foundation and bringing in that network into NASA. And so by early 1990, here was the NASA network. It was connecting not only the Japanese Space Agency, but the European Space Agency, the Russian Space Agency, and nodes.
Okay, so we have a technical difficulty. We have lost Jim. But in the meantime, keep posting your comments, guys. We're super happy to see you here. Yeah, we will be back soon. Thank you for your patience. Metaverse, we have a problem, as Martin says. Thank you guys for your patience. We have Jim. We have lost Jim for a moment. Please stay tuned. Of course, please keep posting your questions. We will be back in a second. Thank you so much for your patience. So maybe in the meantime, while Jim is back, he comes back, I will be happy to answer any questions. I see here is rare. How can I join the Metaverse? Well, honestly, it's super easy. You just need to go to Cluster App Lab, and then you will be able, of course, to create your avatar. You need to first create an account, then you create an avatar, and then you are able to download the Cluster app in your device. It can be from your laptop, it can be from your phone, it can be on your tablet, or of course from the Oculus. It's not restrictive, so it's not an issue if you don't have an Oculus headset. Yeah, you just need like good internet connection, and then you are more than ready to go. We have Jim back. Jim, you are back. I was entertaining our audience, so they are able to hear you back again.
Right. Thank you. Thank you so much. Okay. So indeed, we're back up and running. Let's see. Are we ready now? 2 seconds. All right. Yeah. Okay, so we're going to wait until the WebEx starts coming up. This is a learning experience, of course. Where if you were all in the metaverse, we'd have it made, right? But because we have such a mixed audience, there's a variety of bandwidth problems that occur.
Yeah, absolutely. And in fact, some people from our audience in social media are asking if they can join us inside the dome.
Yeah, I'd love to have them join.
So Israr, if you can join, please feel free to join. I will paste the link of the room in a few seconds.
Yeah, in fact, they can do it on their own computers. You're right.
I think Israr is using his laptop.
Okay, super. Well, we're just about ready to pick up where I left off. All right. All right, we have to test. Everyone can hear me? Okay, super. Okay. Oh, you had a previous question. Camille, that you wanted me to answer?
Jim, do you want to do a quick test, mic check?
Yeah, testing, mic check, test. If you were, of course, in the metaverse with us, you would hear me clearly. But all right, everything going well? Are we ready? Everything going well?
Yep,
we can
ready.
Yep, we're ready again.
Yep, we're ready to go.
So we're gonna start.
All right.
Apologize to the audience,
Wonderful.
which this is obviously a new technology.
All
We're trying
right.
this.
Wonderful. All right, indeed. Let me begin
All right.
by
Indeed,
apologizing to everyone that these new technologies where we're actually blending many things together have their associated problems.
These new technology blending.
Okay, I'm waiting for the final sign to get started again.
Okay, it started.
Jim, you want to do another mic check?
Okay, testing.
Okay. Testing.
That's good.
Yes.
Yeah, we're good.
Mic check,
Thank you.
testing.
Yes, mic check.
Is it
Mic
breaking
check.
up?
Oh, we're good.
We're good. So
Thank
now
you.
we can start again. Again, sorry for the audience. And Jim, you're ready to go.
All right, fantastic. Thanks so much, Jacob and Wasim, for working behind the scenes, making this connected into so many other venues. And once again, we apologize for that, but these new technologies that are merging and diverging as they will go in the future, of course, give us a perfect opportunity to talk about what's happening in the metaverse. So the next big disruptive technology was indeed the World Wide Web. So in the early 90s, my organization at NASA Goddard was able to start developing a series of web pages. In fact, the National Space Science Data Center that I managed at the time was number 200 on the World Wide Web. I mean, it was just starting out, 1993, but we developed NASA's homepage, and now it's quite ubiquitous. And of course, by later in that decade, 1997, the Public Affairs Organization took over the organization of and management of NASA's web presence. Once again, a disruptive technology that then becomes a standard, not only for scientists, but indeed the public. So what are we talking about here in terms of these evolutions that are happening using the network structures? Well, once again, 1990 to 2005, this was the World Wide Web. This was basic web pages, HTML. Some e-commerce was starting, PayPal and Amazon. Web 2, now much more social media. This is where we have all kinds of applications as the internet becomes much larger with much more global access associated with it. This includes data monetization, where we're now databases and other kinds of information that's gathered by people that are participating becomes important, not only security, but to protect, but to use appropriately. Cloud storage comes in and its access. But now we're moving into a new environment. It's called Web 3 or 3.0. This is where non-fungible tokens are starting, semantic web, the metaverse, blockchain, artificial intelligence, interoperability, and this is becoming a reality as it's moving forward. Now, some of the differences between Web 2 and as we move into Web 3 are talked about here. The internet is a network of billions of computers, millions of servers, and other electronic devices. And once online, internet users can communicate with each other all over the world, obviously, and view and interact with websites, buy and sell goods and services. But the growth of the internet has spawned many of these services to remote locations and improve those for many of the many countries all over the world. And it's leading the way to the creation of the metaverse. So the metaverse doesn't compete with the internet, it builds on top of it. So the internet is something that people browse, but people create experiences in the metaverse. All right, so the metaverse then is globally connected an immersive digital space. It rides on top of the internet, in other words, but provides three-dimensional views and feelings. This means it's a digital world that merges virtual reality, augmented reality, extended reality, and artificial intelligence. Now, it's at various stages of development. Some aspects of the metaverse is more developed than other aspects. In fact, these components are going to require additional bandwidth. And we just experienced that problem a little earlier as we're bringing on more devices, web access, broadcasting over perhaps LinkedIn and many other aspects of this talk. So to provide quality access, we really need that adequate internet bandwidth. But that's going to happen. That is in everyone's mind. Many countries are building stronger internets, and that will do nothing but improve over time. So to anticipate this new bandwidth, the metaverse is really starting to evolve into these three-dimensional opportunities, using these fantastic types of reality. And it's expected to continue to evolve in the coming years. Now, it may take several years, but what I want to do today is really concentrate on things that are up and running. Now, some of the most important elements of the metaverse today is really in the area of virtual reality. This has really been pioneered by a lot of the gaming industry, where simulations of a three-dimensional environment that enable users to interact with their surroundings. In fact, some people get a little nauseous because of the immersion and seeing things in three dimensions and experiencing them, moving them in different areas and seeing how they move, and that gives them all kinds of insights as to the type of objects that they're observing and experiencing. And this starts, of course, by having a VR headset. I am sitting in some conference room in Ames, Ames NASA Center in Mountain View, California. And users, some in the audience right now, are from various places in the world. They are in Europe, they're in Pakistan, they're in the Middle East, they're also in, of course, in the United States, even in this room. Now, virtual reality is going to increase and be integrated into the metaverse. What's not completely done, of course, are the areas of gloves and vests and full body tracking suits. But most of that will come along and be brought in even easier. Now, there's an area of what we call augmented reality. This is where it's less immersive. Many may start out using a pair of glasses that then add to their environment things. They may see a path to walk from one place to another while they're walking in a town because a map has been downloaded and they can get to the place that they need to go to. And so it adds a new dimension to their experience. In other elements, like the Pokemon Go is an early example of augmented reality, where you can then hold up your phone and see things that are invisible, so to speak, because it's not reality, it's sitting on your phone, but geolocated to exactly where you are to see something that then is an element of a game. There's also extended reality technologies, and this combines elements of the real world with the digital world to create new kinds of interactions and perceptions. So what's a new car look like in my driveway? What does a new set of buildings and how they are integrated together? And so these extended reality technologies can be used in the workplace and collaborative, and that will also increase over time. And finally, a new element that's incredibly important in the metaverse are digital twins. When we're talking about digital twins, we're really meaning we can create in this space in virtual reality, a complete structure with the look and, of course, the functions in many cases of the actual object. Here's an example of having a plane, with a pitch, yaw, and roll, it being experienced in a virtual reality setting, and it models exactly how a real plane would do it. So these digital twins then, of course, are incredibly important for simulation and training as we move forward. And for example, digital twins of spacecraft can be used to train operators on how to move a rover or how to move and operate a spacecraft from space. And that's where we get into now much more of the space applications. This is one of my favorite areas of the metaverse, of course, where we're doing things in an augmented reality basis and virtual reality. One of the most important elements in the metaverse, of course, is astronaut training. This is where a virtual reality system of the entire exterior of the International Space Station has been created. This is incredibly important because an astronaut can put on a VR headset and then practice that translation path as they move out of the International Space Station, make their way down this huge structure to a module like the Columbus module in this example that's shown, and do that to then begin the process of mounting an instrument installation. Now, this is incredibly important because you can get the lighting, you can get the orientation of the International Space Station. You can do this in the time frame that has been scheduled. Now, these things, these low Earth orbiting satellites, and that includes the International Space Station, orbits the Earth every 90 minutes. But the longest EVAs can be hours. The longest EVA was nearly 9 hours. Can you imagine working in the dark? Every orbit you'll have to go through. And so when does that happen? Where will you be in your test? You get the whole look and feel. That's incredibly important because you can practice it as many times as you need to before you take that next level that astronaut training requires. And this, of course, is the water tank. The neutral buoyancy laboratory at Johnson Space Center. Before that, there was the neutral buoyancy simulator at the Marshall Space Flight Center. So immersive water experiences have been used in NASA for more than 35 years. And so consequently, this requires a lot of additional people to be able to be involved. You have safety divers and camera people and many others that are in these water tanks. But now, before you can practice these things, you want to be able to minimize the exposure in these tanks with all this labor. The VR reality systems are important. Now, here's where also new things will come about, where we can talk about astronauts and also some of the things that are happening to them. So let's see an astronaut in space and how they might operate. And to do that, I'm asking Cam, there he is, to provide us with an astronaut. There they are, they're suspended, they can move in various directions. They indeed are experiencing this free dimensional experience, and we can talk about what's happening inside, like a beating heart. If we have a beating heart, we then can talk about how in space the effects on the heart, and the effects on the heart are such that you have not the pressure that you need. The heart muscles don't need to work as hard. They can pump that blood anywhere, and it becomes a much easier task. I mean, this brings up concepts of how heart disease might be studied in space, places where one can go and be able to study the heart as we might need to be able to find mitigation strategies for people that are running into medical problems as we have it. Okay, other things that are happening in space. You can go on to the next concept, and that is what's happening at NASA in the area of the Mars Challenge. NASA is hoping to use virtual reality simulations to learn more about Mars and how humans can potentially survive on the red planet. And of course, using Epic Games virtual reality software, Unreal Engine 5, developers have created a new VR environment and be able to set it in the stage, the backdrop of Mars. These developers are tasked with adding NASA VR simulations to new assets in one of 5 categories. You know, the setup, the camp, the scientific research areas, the exploration, all these kind of things then are producing challenges that offer, you know, NASA's offering 20 prizes totaling $70,000 in each of these categories. Now, developers now have 80 days to complete the challenge, and we'll see what comes out of that. But here in the metaverse, we can also begin the process of how things might work on Mars with perseverance and ingenuity. We have full models of perseverance and ingenuity. Here's Percy. It's a fabulous rover on the surface of Mars. Here's a digital twin of it. We also have ingenuity. I can just sort of reach up and grab ingenuity here and then be able to move it, you know, and simulate how it operates in this environment and how these two work together. Indeed, humans on the surface of Mars will have robots that will be working with them. You can imagine them working in the field and turning to a robot to do a variety of analyses and then communicate those results, indeed, back to their home base. All right, let's move on to new things. Indeed, the European Commission is involved in studying Earth digital twin. We can get rid of perseverance and ingenuity now. And so this new destination Earth, it's called, is partnering with many organizations like the European Space Agency, EU METSAT, and others. And the aim is to develop a global scale, highly accurate digital model of the Earth to monitor and predict the interactions between natural phenomena and human activity. So we're going to be seeing more of these activities as many of the space agencies indeed are going to be contributing data to this effort. There's also fabulous art galleries in the metaverse. Here's Alicia's art gallery. If you haven't had an opportunity and you wonder the metaverse, this is a fabulous art gallery. This shows some of the aspects of generative AI technologies. This set of art was generated indeed by artificial intelligence. Well, here we are in a classroom developed by the Metavisionaries. And so this is a venue for space education. And in fact, we've already had a series of classes, things about satellite applications that we've talked about in many ways here in this particular classroom. This has worked incredibly well. For instance, we've had classes on orbit mechanics and electromagnetic spectrum, humans in space and remote sensing, position, navigation, timing, satellite communications, and space policy and law. In fact, Jim Adams, who's my former deputy planetary science division director, was really the first to discuss spacecraft subsystems and then build that spacecraft from parts in the metaverse. So this concept is a forerunner to the development of new things like a mission concurrent design facility. So here we have a variety of models, not only our spacecraft components, which we then can visualize. Jim used an array of components that we'll see. Cam, can we bring those up? In addition to that, we have indeed discussed, there's the parts. We see solar cells, we see engines, we see all kinds of instruments and things that Jim used to bring over and literally assemble right here on the stage as spacecraft, giving the audience an opportunity to really understand how these things fit together. This can be quite mysterious, for instance. You know, you may not really realize what it takes to really build a spacecraft, but there's a lot to it. Now, in addition to that, there are special orbits for spacecraft. You know, so let's look at the three main types of orbits. Here we have the Earth. And with the Earth, we have low Earth orbiting spacecraft, medium Earth orbiting spacecraft, and then, of course, much further out, we have geostationary spacecraft that orbit the Earth. Now, of course, the Earth is spinning, and these are not moving. They should be moving in real life, but it gives you an illustration, indeed, of where they are situated and the kind of observations that they make. Now, another thing that's happening in the metaverse, we can now get rid of those, is a variety of important interviews. I've had an opportunity this week already to talk to a number of Ames scientists and engineers about the activity, the fabulous activity that they're doing. This would normally be a podcast. And in fact, the audio interactions are easily streamed and podcast. But the new dimension, of course, is adding that by doing it in the metaverse, having the opportunity to visually see many of the things that are being discussed. And some of the visual models that we use in this are something like the Hubble Space Telescope. So how big is the Hubble? And we can bring that in right now, and we can see the enormity of this spacecraft. This is a fantastic spacecraft. There's grappling systems that have been used to capture it, bring it in the shuttle bay. You get the look and feel of this Cassegrain telescope that then has instruments in the back and a 2.8 meter mirror. This is just a fantastic telescope. It's been a real workhorse for NASA, and being able to visualize it is a real treat in the metaverse. And then, of course, we have major connections to Ames. And this started in the Planetary Science Division. So in about 2015, my organization, through Kristen Erickson, began the process of funding Ames to create this three-dimensional site, NASA 3D resources, we call it. This was because of the advent, more than anything else, of 3D printing. Now, 3D printing, of course, connects well with the metaverse. This site is used extensively and has been greatly expanded over the years. And so, indeed, we now have opportunities to really start building new models and new things. Relative to Ames, a new model that we have, we've actually pulled it off this site, is the Kepler spacecraft. Now, Kepler is one of the most fantastic missions NASA has ever launched. Many may not realize is that this is a Planetary Science Division discovery mission that was selected. The administrator at the time, associate administrator of SMD, then moved the selection of Kepler out of the discovery program and gave it to astrophysics. But Planetary Science Division still funded many of the mission managers and working with Ames to be able to make this a tremendous success. Well, of course, let's get rid of Kepler, but show what Kepler is really doing, what it's all about. It's really all about finding exoplanets. And one of the most fantastic exoplanet systems that have been looked at by many spacecraft, including Kepler, is the TRAPPIST system. So we've just now started to begin the process of implementing, the dwarf sun, but also all the major planets, the 7 planets. Right now, you see the planets are orbiting. They're doing it since we just put this together incorrectly. We haven't implemented Kepler's laws yet, but that will come along with time as we develop more and more of these models and then begin to use them in a teaching framework like this. Now, what's really exciting here at Ames is here we go, this planet right here, Kepler, TRAPPIST-1b, there it is, that one that just passed by me. That particular planet's been now observed by JWST, and it's found to not have an atmosphere. It's found to be now sitting closest to the star, where the star's activity is probably really hammered the planet over the 5 or 6 billion year old planet that it is, and eradicated its atmosphere if it ever had one. And so we're finding these fantastic things out, and now we can update and add to the model more and more information as we go through that. All right, if we can now bring up another model. This is our last one for today, and here at Ames, I wanted to be able to bring up Viper. So here's Viper. This is Ames's new mission that's going indeed to the South Pole of the moon. It's going into the areas where we believe there are trapped water, but also many other volatiles that have come in over the 4 billion year plus old moon into these permanently shadowed regions. And this has now been a fantastic mission. We're really looking forward to what it will discover. But now we have a venue. Now we can see the size of this rover. It's not a small rover. It has all kinds of capabilities for drilling and analyzing what it's finding, and then, of course, radioing that information back to Earth. Absolutely spectacular mission here at Ames. Well, finally, let me also mention in closing that artificial intelligence will also be a big and future implementation in the metaverse. And this will change how we do things, even in this venue. More storytelling will be possible. I can imagine that storytelling will be one of the essential elements that will be done in the metaverse, because with the help of artificial intelligence, you can literally prompt objects into existence. And that's what it's called. You can talk to an AI system in the metaverse in the future and tell it to develop such and so capability with this and that, and it will create it, and create the parts, the pieces. And then as you tell your story, it will come into existence so that you can be able to use it. And these things will be integrated in a much more streamlined way into the metaverse. Well, let me now take questions, for the simple reason, this just is a very short little overview of what's going on in this particular area. And we're just really excited to be here at Ames to indeed continue on talking with gravity assist, their scientists and their engineers, and then have an opportunity to let people know what's happening in the metaverse. Thank you very much. Thank you very much.
So thank you very much, Jim, for an excellent talk and truly disruptive technology, both in what its capabilities are, in our capabilities also to share it with the audience in 2D and in 3D.
Thank you. Thank you.
And I can't wait till the day that we could actually see emotions and interactions virtually. It's actually will be very helpful in meetings and so on. So I'm going to go through a few questions as we go through it, and obviously you could expand on them as you feel is appropriate. So the first one is, what are the biggest obstacles you're encountering as you build out these applications in the metaverse?
Well, I think all the rendering that has been done, it just takes a little time to do. There's the Metavisionaries, but many other organizations have key experts that are able to do that. That just takes a little time. Once again, the things that we're having trouble with, of course, are bandwidth of the networks. We try in this venue to make it as ubiquitous as possible that anyone can walk into in this venue. In fact, we have a person from probably Asia somewhere came in, sat down in the audience, and listened to this talk. That's pretty spectacular. But network bandwidth, also the headsets are going to improve over time. As I mentioned, more things like extended reality, augmented reality, but in particular, artificial intelligence connections and applications will come in very strongly into the metaverse. Now, some of this is also going to be pioneered and developed by the gaming industry. We're able to do the things we're doing right now in the metaship. I mean, just look around this fantastic metaship that's been developed because the gaming industry has developed these frameworks and enabled us to then use our imagination and creativity to be able to create this particular venue. It's going to do nothing but improve over time. But as you can see, it's already tremendously capable.
So this is sort of a personal question. How do you see competition being a positive source to developing the metaverse? And I say this since every metaverse platform obviously has some flaws that are based on the humans that are putting it together in the first place.
Well, I think probably the competition is good in one respect. It has one part to it that needs to be worked out, and that turns out to be standards. As competitors be able to develop and build certain things in the metaverse and create their own standards, they then end up doing their own thing. Betamax was before VHS, and now then it turned into DVDs, and then of course now we stream these things. So this evolution has to occur. So we're hoping that more standards will be implemented that will enable us to then interplay where groups as they build can actually take advantage of other things that are being built by other organizations.
So obviously a follow-up that goes along is, what are data mining privacy concerns with uploading on the internet, especially with implementing AI? And this flows also into government controls of export control items and various things, because it brings all the world together.
Those issues are being those issues are being tackled right now. Web 2.0. I mean, we're seeing those issues that are happening. The concept then is, do we wait to develop Web 3 before all those elements are known? No, we're not going to do that. That's human nature. We're gonna move on. One needs to be, as a part of the voting public, aware of what's happening, such that you then can bring in the appropriate people that will do the legislation that will then protect the privacy, but allow flexibility for users to be able to get involved in these things and participate more over time.
So do you think that, let's say if a team is working on building a satellite in the metaverse, that it will help find risks, or it might hinder identification of risk as the team is working in the metaverse and not in person?
Yeah. Great question. I can't help but think back to one of the first spacecraft when I was at Planetary Science Division that we lost. And this was a Mars Global Surveyor, fabulous mission. But one of the operators was given the responsibility to move the spacecraft at a certain position, requiring solar panels to then move accordingly. And this ended up becoming a major operational problem because it violated what we would call constraints. I can imagine us then, if we had a complete digital twin of Mars Global Surveyor, executing those commands first and then recognizing the problem that would occur that would move the spacecraft away from the sun, causing then also our inability to track it and its inability to be able to be powered, or to obstruct a view of a particular instrument by a certain set of commands. One hopes when we develop these kind of systems that all aspects of these commanding systems have been thoroughly executed on. And I think a virtual twin would have really aided that. Now, that's just one element of so many. You mentioned the concurrent design. I think our ability to move into an environment where we can take expertise from many different locations, whether it's in one space agency and another, coming together to design a spacecraft for which it has different instruments from different countries. And these instruments have all constraints. They have viewing issues, they have power issues, they have size issues, and be able to construct them. And everyone then gets the insight as to how the spacecraft comes together. That's a concurrent design facility. NASA has several of them. ESA has several of them. These agencies do. But they're done in a room where people come in and they use their expertise, and the interaction is intense. And I think providing an opportunity to do those things in the metaverse really enables people to be creative because they're in their own space. They have an opportunity to check things and bring their expertise right back into a metaverse room to be able to better the design. I think we'll see those kind of things happen. There'll also be aspects of the design that could be accommodated by artificial intelligence. You could query an AI chatbot on the latest structure over some issue, and then get some insight as to what it might find that has happened historically with other spacecraft. Has this been a problem in the past if we implemented it this way, and get an answer? So what happens so much in the space program is, in many cases, it's thought of like what we call black art. It requires expertise and the really ability. But as we get those people retire, how do we learn that? How do we bring that material forward and then help our designs? Or are we destined to redo the same problems we've encountered before? And we have to work hard to find venues where we can avoid that. And I think the metaverse is going to be one of them.
So just to you and everyone else, I'm going to try to combine some of these questions that I see to the best of my ability. I will start because this one just works well with the follow-up is how important will storytelling be in terms of generating content using generative AI?
Well, I think that is a huge area that will be so important to this venue. I mean, I would like to be able to talk in this venue and as I describe things that we may not have three-dimensional models of. A chatbot actually is taking that input and creating that model, creating the commands that then generated, and then I ask for it and it appears, just like Curiosity or Ingenuity, et cetera, et cetera. And it can be anything. For me, it would be in the area of space-related activity, whether it's engineering, space engineering, or science. But it could be, history. It could be, past buildings or an archaeological site, or, something that a storyteller is trying to relay. Even Homer might have really enjoyed being able to talk about about Troy. It's the sci
Sorry, everyone. I just had a issue with the cluster app. I will be connecting. Jim will be back in a second. Apologies for that. In the meantime, you can see how can I enter cluster. When you download cluster app in your laptop, this is exactly the setup. I just log in, then I just try to enter the cluster itself. It's loading. Thank you everyone for your comments. It's very great to see how the community is active here. This is my avatar. Here you can customize your avatar, but then we need to go back with Jim. So we go to explore, and then we go to the meta chip, and then we give it some love, and then we hit on go, and then we try to go immediately back with Jim in the lecture dome. Apologies for the interruption, but then we are just coming in again.
Sure, these are going to be fantastic things that we'll be able to do.
So the next question I'm going to ask is sort of a combination of various questions. Obviously, the metaverse, as we see it now, is a three-dimensional virtual reality space. What are there in developments, as you see it, the etiquettes and ethics that are going to play in that space? From the simple etiquettes of whether you walk next to the speaker or how you interact with that, how is that going to be implemented and approached? But even on a wider sense, what are the ethics that you need to look into implementing this type of technologies and the positive and negative effects that come in? Part two of this question. Go ahead, Jim.
Okay.
Go ahead, Jim.
All right. Well, let me just think about part one. Here we are with, I don't know, maybe a dozen people in this particular room. 3 or 4 of them, have never been in this room before. These are new students. There's already sitting in the crowd, watching what's happening, taking it all in. I think etiquette-wise, these are just tremendous opportunities. Welcome to our new students that have arrived, that are participating in this venue, and they just dropped in. So to me, that's very important etiquette, the ability to not be disruptive in the environment, but take the environment and participate in it. When we had models out front, if we had more time, I would have everybody in this room come around Perseverance. Perseverance was one of the missions I helped sell, indeed, in the metaverse. And I'm sorry, into NASA and now into the metaverse. We can walk around Perseverance. We can talk about various pieces of it, and we can interact on a much more one-to-one basis because of that. Those are wonderful opportunities, and indeed there'll be an etiquette that will be expected. We'll expect people to be able to drop in. This is an open room. Anyone can walk into this room given a VR headset and the cluster model, and be able to come in and participate. And of course, what's happening here is we have somebody going to be building the spacecraft, or taking a variety of parts to do that. And maybe ask for participation from the audience as they come in to be able to get it. So yeah, so what I would do is I'd move that, and then I'd stick that other one in there in the center. There you go. Put that one in there. That goes in the center. Yep.
Very good. Yesterday, I think I touched in Wasim's conversation about the question, or maybe afterwards we talked about we try to make the world a better place. And so the ability to have and have not creates different issues. And currently this technology is quite expensive. So we have to look at how that affects across globally. But another point that came out from a question from the audience is, how will the metaverse be developed for accessibility? Can someone who is blind, deaf, etc., be able to participate?
Yes, those are all very important questions. Let me just tackle a couple of them. Indeed, it can be thought of as being expensive if you want to immerse yourself and you have, a set of VR goggles. Those are right now heavy on the head. They have their own drawbacks. It takes, over time, it'll take time for those to be able to get slimmer, cheaper, and easier to use and be able to last longer. That will help, but they'll also be expensive. Now, this particular environment that we're in is called Cluster. This was developed in Japan. It gives us the framework that we can create our metaship, but you actually can look at it on a browser, on your computer, and get a slice. You can be part of the action, but not spend the amount of money that you need for a VR goggle headset. So consequently, there are those things that are coming on that are really important, that are very helpful, that I think will make it bringing more people into the metaverse. So one, it's going to get cheaper and better for the headsets, but still expensive. Two, opportunities to be able to take views of what's happening in the metaverse by participating using a browser technology and be able to get into these rooms. Accessibility is indeed also has to be tackled. And as they try to tackle that over time, the gaming industry, once again, is probably working on a variety of aspects of this, where you can describe environments that then lead people into the approaches and let their imagination be the metaverse. I mean, for people that are blind, but do indeed hear. The other way is for people that are not visually impaired, but have hearing loss. That can be solved almost today with text information. Above our heads in this room, I see everyone's name. I can see that you're on mute, but as you talk, you could actually have a light come on, and then indeed the text of what you're saying be there to help those people that are have hearing loss, that are deaf. So these technologies need to be integrated and done much better. Okay, and of course, here's the International Space Station.
So
we didn't talk about all the models that we have. But this one I particularly enjoy. So here in my JSC slide where they were translating how to module. Right above here is the Columbus module. Here's a set of exterior experiments that they were connecting into. That can actually be seen by the cupola, which is right here. So you could have an astronaut sitting there looking at what's happening as they translate out of a hatch, working their way all the way down these the modules over to the Columbus module. Actually, this is Kaibo. This is the Columbus module over here. I was wrong. Sorry about that. So here's Columbus. This is the Japanese module on this side, and then they have exterior experiments. Yeah. So the hike that was shown was even more difficult because it was really going over to this far module. Still could be seen a little bit from the cupola. Yeah. Fantastic. You can really get a view for what these things are like.
So Jim, one last question.
Okay.
And this is more about employees at work. We have employees who aren't even fans of virtual meetings without headsets. And as you know, we're going into a hybrid scenario of work. Any advice on how to get those employees excited about using the metaverse and avatars to communicate or to do seminars as we're doing now?
As we're doing now. That just takes time, I think. Everyone that comes into this sees their own advantages, and there are disadvantages. As I mentioned, the headsets are can be heavy. I've had mine on now for more than an hour and a half. You know, I'm ready for myself to take it off. You know, so there's only so many hours in a day that I can do this, but it's tremendously exciting and stimulating. I find that every time I come into the metaverse, into the meta ship to talk about these exciting things, I too learn from the audience that are coming from all over the world. So every time we do these things, you have to be able to have an open mind and continually try them. If you're one that's interested in trying new things and making them successful, then you will fit in the environment and succeed as the environment moves forward. And changes will be occurring, making it easier and better for us to be able to do our business in space by also being in the metaverse. Well, once again, let me end by thanking Ames, who has hosted me this week. I'm very excited to be here as a retired NASA employee, one of my favorite centers to really interact with the scientists and engineers and enjoy my week here. So thank you very much for attending.
Thank you again.
Come on down. Let's talk about Space Station.
All right. Thank you again, Jim. To the audience, thank you for participating. We will end now. Thank you again.
Okay, super. Okay. Anybody have any